Students, this is Unit 8, Area and Solids, Lesson 8.2, Area of Regular Polygon. Please, students, do not attempt to multitask as you're working on this video. Turn off all other distractions. Focus on the task at hand. All right, I'd like you to find the area of the following shapes. I'd like you to challenge yourself to do this without a calculator, friends. Finish this page on your own, then restart the video. Welcome back, friends. This is a trapezoid, so it is going to be area equals a base, the average of the bases, times the height over 2. So my area is going to be one base, which is 6, my other base, which is 8, over 2 times my height, of course, here, which is 3. And you should have, that's going to be 14 divided by 2, that is 7 times 3. We have 21, check for units, centimeters squared. Down here, that is a parallelogram, area equals base times height. Your area is, the base is 30 times the height, makes that right angle is 9. Don't touch a calculator, hopefully you didn't. You simply multiply the first there, and we get 270 millimeters squared. Down here, this is a kite. A kite is area equals one diagonal times the other diagonal over 2. Super important you actually trace this. Your one diagonal, when you trace it, that's 9 times your other diagonal. Careful, that was not 3. On average, there's at least 1 out of 5 of you that wrote 3 there instead of dragging it out and getting the whole 6. Divided by 2, that's because you did not physically trace. I'm going to take my 2 into the 6 and make that 3. And that is going to be meters squared, 27 meters squared. Alrighty, so today we're going to talk about area of regular polygons. And there's some new terms you're going to be familiar with. Of course, an acute, obtuse, and right triangle. You guys are familiar with that. The term regular, meaning all sides equal. And then here's a new word, apothem or apothem, depending on which textbook you look at, and the radius. Yes, you'll need a calculator, and I do recommend colors. Quick recap. The area of any triangle is simply base times height over 2. In an obtuse triangle, remember that your base and your height, the height is on the outside. And most importantly, in a right triangle, your base and your height are actually the legs. One leg times the other leg over 2. But basically, again, triangles are base times height over 2. So let's practice that with one problem. Underline the key words as we read. The area of a right triangle is 6 centimeters squared. Longer leg is 4. Find the length of the hypotenuse. The key words here, of course, the fact that we're dealing with area. A right triangle is, that's an equal sign. Longer leg 4, find the length of the hypo. Super important, you draw what you are reading. First off, it's a right triangle. And the area is 6 centimeters squared. Notice as I account for stuff, I cross it out. The longer leg is 4 centimeters. Our ultimate goal is to find the length of the hypo. Now, this would be so easy if we had 2 sides, need third side, but that problem is you don't even have 2 sides. You have to work with what you do have, which is the area. And the area equation is leg times the other leg over 2. Let's see if we can work with that. Notice the areas are the same. I'm going to plug this in over here. 6 equals 1 leg. Circle, plug, chug. Times the other leg that we don't have over 2. We're going to solve here. We just found that your unknown leg is 3 units. Now you have 2 sides. Have 2 sides, need third side, but that. Finish this problem on your own. Give you about a 10-second lead here. See if you can beat me. Okay, so that's a recap in working with right triangles and the area of triangles. So this page you're going to do on your own as a quick recap of area of triangles in general. Do this on your own. Pause. Welcome back. Let's see how we did here. This one, again, you should have 12 times 4 divided by 2. I can simply do 12 times 4 divided by 2, or I can just reduce one of these and get it right off the bat. It's 24 millimeters squared is your answer there. This one, your base is 5. Your height is 3. 5 times 3 over 2. Yes, decimals are possible. This would be 7.5 centimeters squared is the area for that second one. So here we have an obtuse triangle, and its area is 70, make that a 7, 72 centimeters squared, and area equals base times height over 2. You circle plug chug. 72 equals my base I don't know, but my height I do know is 6 over 2. I'm going to take that 2 into 72. 6, that's 3. So I basically have my base is going to be 72 divided by 3. And that is 24, check for units, centimeters. That is your base. If you got any of these wrong, you should write a little note of reflection. Now, we're going to work specifically with what's called regular polygons. Regular polygons. Regular polygons. This is a regular polygon. I'd like you to write out what makes it a regular polygon. Fill that blank by yourself. A regular polygon has congruent sides. That's where all the hatch marks are. And all of these angles are going to be congruent. Congruent sides, congruent angles. Now, parts of a regular polygon. There's some vocabulary here that you need to be familiar with. The middle of a regular polygon, the exact center, just like the center of a circle, that is called the center. Now imagine all regular polygons can be inscribed inside a circle. So if you connect the center to the corner, and notice that's also if there was an imaginary circle that go right to the circle, that's called a radius. So center to corner is a radius. Center to corner is a radius. So that is a radius. Any center to corner, draw another one in, that's a radius. Those are all radii. There's a new word called the apothem. That is going to go from center to the midpoint of a side. That's called the apothem. Center to midpoint, and it always makes a right angle. From center to midpoint of a side, that's called the apothem. Do not confuse those two. A radius, center to corner, apothem, center to midpoint. If you look very carefully, trace up the radius, down the apothem, and across, you see that there's a right triangle there. Watch out for that. We're going to be using that in a little bit. So whenever you're working with regular polygons, I always want you to physically trace the perimeter. Do not use your eyeballs. Okay, ready? Let me show you what I mean. Trace this right there. Trace it. One. Keep going. Once I physically trace it, I see that define this perimeter, if you were to walk it around, that I'm basically doing 8 times 8. So my perimeter would be 64. Check for units. There's no units, so I just write units. So what I'm trying to impress on you is whenever you work with perimeter, physically, trace and count. For example, that's 1, 2, 3, 4, 5, 6, 7, 8, 9. So my perimeter is going to be 9 times 10.2. And of course, that's going to be, my perimeter is 91.8, and it's not unit squared, it's just units because it's perimeter. So whenever you work with perimeter, I want you to physically trace your edges. Always. Do not trust your eyeballs for that. Let's recap. To find the area of a triangle, once again, it is simply going to be base times height, because it's half a parallelogram over 2. So triangle area is base times height over 2. I'd like you to rewrite it again, just to remember. Now, the equation for area of a regular polygon is directly related to what we're just learning. Okay, if we were to look, I'd like you to shade just this one triangle, just shade it. Okay. Now, in this one triangle, squiggle that, that's the base, right? And in this one triangle, this red segment is the height. Now, if you were to find the entire polygon, you see that it's basically a bunch of triangles. So there's a long way and there's a short way. The long way is to find one triangle and then walk it around and add them all up. Here's the short way. If I want to find the base of one triangle, ready? Trace, say base. That's the base of that triangle. Keep going. Base of that triangle. Base of that triangle. Base of that triangle. Trace all the bases all together. So you see, if we put all the bases together, all the bases combined are the perimeter of the regular polygon. Center to midpoint, center to midpoint. That would be the apothem. The height gets replaced with the apothem. So you can see here, we can swap out, wherever we see the word base, we're going to swap out the word perimeter for a regular polygon. And whatever we see apothem, we're going to swap out the word height. We swap out the word, we get apothem. So in a regular polygon, we swap out base, put in perimeter. We swap out height, and put in apothem. So your final equation is this. The area of a triangle is base times height over 2. Regular polygon, it's going to be perimeter times apothem, I'll just use A, over 2. Perimeter times apothem over 2. So a triangle is going to be B times H over 2. A regular polygon is going to be perimeter times apothem over 2. Let's do these together. I want to find the area of this regular polygon. So first, let's count our sides. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 sides. First thing I'm going to do is I'm going to find my perimeter, which is 9 times 10.2. 91.8 units. Just found ourselves our perimeter. Let's write our equation. Area equals perimeter times apothem over 2. Perimeter, 91.8, times the apothem, 14, over 2. Yes, I could easily multiply those and divide by 2, but because I'm not using a calculator, I'm going to simplify just a bit. Let's take that 2 into the 14, that's a 7. Now I'm down to a single digit, so it is easier to multiply. So we just found our area is going to be 642.6, check for units, units squared. Some of you are freaking out that we didn't do a calculator, so I'll show you on a calculator as well. 91.8 times 14 divided by 2. See, it is possible to do it without a calculator. Try this. Area of a regular hexagon has an area of 680.4 centimeters squared and a single side length of 16.2. Find the length of the aperture. Always try to draw and label what you've been given. First off, it's a hexagon. We accounted for that word. Let's write our equation out. For area, we have area equals perimeter times apothem over 2. Let's circle plug check what we have here. Always physically circle your equation. So we're going to circle the word area. Plug it in. Perimeter, be very careful. 16.2 is not your perimeter, folks. You need to walk it around. Walk it around. That's 16.2 times 6, of course, because it's a hexagon. And 97.2, that's our perimeter. Our apothem, we don't know. Let's leave it blank. It's over 2. Drop that over 1. You can see we're going to cross multiply here. We've got 2 parentheses. I don't like to touch the calculator until the variable, which is right there, is by itself. So now we can do this together. You can follow on your own calculator. I'm going to go 2 times 68.4 divided by 97.2. And we found our apothem is 14. All right, folks, this page you're going to do on your own. Pause the video, restart when you're done, have a red pen handy to check your work. Pause the video, do your own work. All righty, welcome back. You have here area equals perimeter times apothem over 2. Perimeter times apothem over 2. So we go here. Always physically trace your perimeter. And your perimeter is 5 times 16. Our apothem is 11 over 2. I'm going to do this. I'm going to take that 2 into the 16. That's 8. And I get here 40 times 11, which is going to be the same as 400 plus another 40. And we get 440. Check units. No units. Units squared. Our perimeter, we walk it around. 1, 2, 3, 4, 5, 6, 7. 7 times 11.3 times your apothem, 7.7 over 2. Physically trace. In general, almost a third of you did not physically trace your perimeter. You got this wrong. So if you're one of those third that got it wrong, make sure you write yourself a note on what to do differently next time. 7 times 11.3 times the apothem, 11.7 divided by 2. Decimals are fine. 462.735. Check units. There's a lot of equations that you have to have memorized, folks. So I have something new that's going to help you memorize them. First, let's fill out the blank. Area of a rectangle, length, width, length, width. And a parallelogram, base height, base height. A triangle. One-half base height. A trap is half height sum of bases. A trap is half height sum of bases. The dot equation that I just wrote, half height sum of bases, that's what you're going to find in the back of textbooks. It is the exact same thing as averaging times by the height. It's the exact same thing. This one is just found in the back of most textbooks. Half height sum of bases. It is the exact same concept going on right here. Last one. Regular Polygon, 1/2 perimeter times alpha-thumb. Perimeter times alpha-thumb. Alrighty, folks, this tune goes to the tune of the answer marching one by one. Okay, it goes like this. The area of a rectangle like this, and around base height, a triangle, 1/2 base height, a trap is height, base is an area of a regular polygon, 1/2 perimeter at the thumb. Boom, boom, boom. Those of you who sing that camp song, let's try it one more time. The area of a rectangle length width, the parallelogram base height, a triangle, 1/2 base height, a trap is height sum of bases, an area of a regular polygon is 1/2 perimeter at the thumb. Boom, boom, boom. We will sing that with gusto in class. Be prepared.